Your Node-RED dashboard is great, but it is stuck in your control room. Let's take it global with Remote Red. In the last episode, we got the PZEM-0040 Energy Monitor dashboard up and running. We can enable remote monitoring and control of Node-RED dashboard with a smartphone. But first, we must head on to Manage Palette in Node-RED and install Node-RED Contrib Remote. This will make available the remote access, remote notification, and remote question nodes in the Nodes palette. The remote access node provides remote access to Node-RED dashboard from a mobile phone. All you must do in the remote access node is to add a remote config node from here. You should keep most of the settings in the config node, but could change the base URL to point to your dashboard and select the server location closest to you. Click on Connect Remote Red app to display the QR code. Now go to your smartphone App Store or Google Play to download the Remote Red app. Select Add Node-RED Instance and scan the QR code in Node-RED to connect the app to the Node-RED dashboard. Add the config node and deploy the flow. The remote access node should display serving, and the Remote Red instance should indicate green. You can now select the instance to load the Node-RED dashboard. With your smartphone, you can remotely control your electrical load with the relay and monitor the power parameter trends and gauges from anywhere in the world. The remote notification node will allow Node-RED to send push notifications to your smartphone, alerting you to abnormal conditions. Select the same config node from the access node. We will set the title and the body of the notification message in a function node. You can use the default notification sound or select any other. Now, let's add the function node and paste this simple script from the GitHub link in the description. Modify the set point to your voltage high alarm or alert threshold. The node should output a message payload with the title, voltage, and the body, high, when the set point is exceeded. Connect the function node to the output of the voltage chart node and to the input of the remote notification node. We will simulate the high voltage notification by connecting an inject node to the input of the function node. The inject node should have a value above the set point in the function. Deploy the flow, then trigger the inject node. You should receive the notification on your smartphone that says voltage high. What if you want to immediately act on the notification? Now, we are talking about the question node. For this, we will replace the simple function script with a more industrial-focused function code, also from the GitHub link in the description. The input validation section of the script filters out invalid data or zero readings when the power is off. It ensures no false undervoltage alarms trigger during downtime. The state management section creates a memory for the node, allowing it to remember previous readings, the last time it sent an alert, and how long the fault has been active. The evaluation and direction code compares the real-time value against your custom thresholds to determine if the situation is warning or critical, and specifically notes if the value is too high or too low. The debounce logic section acts as the noise filter. It forces the system to wait a few seconds to confirm if a fault is real before sending a notification, and prevents alerts caused by temporary electrical spikes. All the parameter data are gathered here, and a live summary of the machine health is displayed under the function node. Finally, the script formats the alert with an editable country-specific timestamp. For example, I have the local code and time zone for Nigeria as EN-NG and Africa/Lagos respectively. Russia will be lowercase ROU-uppercase ROU and Europe/Moscow. And Brazil will be PT-BR and America/Sao Paulo. You should look up the one for your region. The timestamp is then sent along with an alert to either of two outputs, one for warning alert notifications and the other for critical alert notifications. Now, go to the Setup tab and increase the output to 2. Ensure that the notification node is connected to the first output and connect the question node to the second output. In the question node, select the same config, but this time we will set answer 1 to turn on relay with a value of true and answer 2 to turn off relay with a value of false. Then connect the output of the question node to the input of the relay switch node and the Modbus write node. A key feature of the function node is to process the alert of the different energy parameters. This is achieved by passing each parameter value through a change node that defines the set point. Add a change node between the voltage chart node and the function node. Double-click on the change node, set the name to voltage, and change the rules to set message meta. Then select JSON from here. Go to the same GitHub page in the description. Copy the voltage metadata and paste it here. You can adjust these parameters for the current or frequency. These are for the alarm noise filter time and how frequently the warning and critical alert should be sent when the fault is still active. You can get the sample scripts of the other parameters from the GitHub link in the description and edit them to match your requirements. I will now connect 4 Inject nodes to the input of the voltage change node to simulate the different alert levels. The first is set to 244 volts high warning alert. The second to 253 volts high critical alert. The third to 207 volts low warning alert. And the fourth to 175 volts low critical alert. Connect a debug node to the output of the function for the alert confirmation. When the flow is deployed, you should see a summary of each parameter status below the function. Repeatedly click on the iWarning Inject node for about 5 seconds to trigger the warning alert. You should see the debug warning alert with the trigger voltage, time, and date of the trigger. You should also get the same message as a notification on your smartphone. The critical alert, high or low, require just one click. The debug message is similar to that of the warning alert. Since the critical output is connected to the question node, the smartphone critical eye notification has an option to turn on or off the relay. You may repeat this simulation test for the low alert, and even simulate the alert for frequency and power factor. When upscaling your factory with IIoT, the Remote Red app is great to have, and it is free for the initial testing period. Industry 4.0 isn't just dashboards, it is real-time decisions from anywhere in the world. The next episode will introduce you to IIoT machine learning and AI. You can't afford to miss it, so hit the like and subscribe buttons, the notification bell, and share this video with fellow engineers and makers. See you then.